So you've had about 24 hours to work with the nth term test, which tests for divergence only, and then the convergence test applied to geometric series, and to see how that can determine if a series does converge or diverge. We're going to keep those same tests and apply them to not just a geometric series, but something called a power series today. So we'll take a look at that and then define convergence over an interval and a radius. So just to review from yesterday, a geometric series will converge to the following sum if the radius is bounded by this convergence interval. So remember that we established that was r being between -1 and 1, not equal to and not greater than or less than, but between. So we have our geometric series test, which we learned yesterday. If any geometric series has a ratio value that has an absolute value less than 1, then the series converges. So a power series, a geometric power series, is when the ratio is not just a constant, but is a function of x. So you're not just multiplying everything, say, by 2. You're multiplying each term by 2x. So you're bringing a variable into this. So if it is a geometric series where the ratio is a varying ratio, we can say that the series will converge if that ratio, even in terms of x, is guaranteed to have an absolute value less than 1. So we can apply the same thing to a regular geometric series as we can to a power series. We are just working with a variable now instead of working with a constant. So here's an example of a geometric power series. So we can take a look at this by expanding some of the first couple terms. So if we put 1 in, we would have 5x. If we put 2 in, we'd have 25x squared. 3 in would be 125x to the third, etc. So we can see that our r here is 5x. Each term is being multiplied, but not just by the constant 5, but by the variable 5x. So this geometric series will converge if and only if this 5x value stays less than 1 on an absolute term. So in other words, 5x has to be between 1 and -1. So x has to be between 1/5 and -1/5. This is called the interval of convergence. So this power series will converge as long as the x values stay within the region from -1/5 to +1/5. What will it converge to? Well, it's not going to converge to a specific number, but it will converge to a specific expression. And so the sum of all the infinite terms will converge to the same geometric sum that we had from before. The first term is 5x, and then 1 minus 5x. As long as x stays between -1/5 and +1/5. So as long as the absolute value of x is less than 1/5, then that will be true. So there is a sort of a domain. It's not domain, they don't call it domain. It's called an interval of convergence. So as long as the interval of convergence is met, then this power series will converge to the expression 5x over 1 minus 5x. Here's another power series. The first term of this power series is x minus 2 to the first. The second term is x minus 2 to the second. The third term, x minus 2 to the third. So the r value is equal to the expression x minus 2. So we can say this power series, this geometric power series, will converge only if the absolute value of x minus 2 stays less than 1. In other words, x minus 2 stays between 1 and negative 1, so x has to stay between 3 and 1. That is the interval of convergence. If the values of x stay between 1 and 3, then this power series will converge. And what will it converge to? A sub 1 over 1 minus r. It will converge to the first term, which is x minus 2, over 1 minus the quantity x minus 2. In other words, x minus 2 over 3 minus x when I distribute the negative. So again, as long as x stays within the interval of convergence, then this power series will converge to the expression x minus 2 over 3 minus x for any x between 1 and 3. Not equal to 1, not equal to 3, but anything in between 1 and 3. So these are called power series. We say that the power series is centered at the value of a, and that kind of matches up to the expressions here, where x minus a. So this series here was centered at 2. We use the word center because 2 is the exact center of the interval of convergence. That's not a coincidence. So we say it's centered at that number. The interval of convergence is centered around 2. 2 is the middle value. If there's no expression there, like x minus a number, well then it's centered at 0, and the center of the interval of convergence will also be 0. So these are called power series. So your takeaway from today, a geometric power series. So geometric meaning the pattern is multiplication. Power series meaning the multiplication is happening by a variable, not just a constant, will converge to the infinite sum if the radius is bounded by the absolute value of r being less than 1. When we make that symmetric, okay, and remember symmetric is where we have the absolute value is less than r. We call that the radius. The r value is the radius by itself, so it's written in that form. Here's the r. When we make it into a plus or minus on either side, then we have what's called the interval of convergence. So the radius, the interval, the center. A is the center, capital R is the radius of convergence, and oops, I see a typo here. This should say ratio is bounded. Okay. So find everything related to this power series, the interval of convergence, the radius convergence, and the function represented by the sum of the following series. All right, well, what would the r be as I'm multiplying all of this out? Well, if I put starting with 0 here, I'll have negative 1 to the 0 and x plus 2 to the 0 plus negative 1 to the first, x plus 2 to the first, negative 1 to the second, x plus 2 to the second. Okay, we're moving our way through this infinite power series. So the r is negative 1 and x plus 2. So both of those are being multiplied each time. Negative 1 is the constant and x plus 2 is the variable. So this will converge if negative 1 times x plus 2 stays less than 1. So we separate our absolute value. And of course the absolute value of negative 1 is positive 1. So we've got the absolute value of x plus 2 is less than 1. So this is written in the form where we can tell what the center is and what the radius is. So the center is at -2. So if we wrote this x minus -2, that would be the same thing. So that's where the center comes from. The radius is equal to 1 because of the value right there. And then the interval of convergence, so we'll take this the next step, and then we'll add 2. We end up with x being between, excuse me, we're going to subtract 2, let's do my math right, -3 and -1. So that is our interval of convergence. And then what will the function be? And the function would be a sub 1 over 1 minus r. Our a sub 1 is that first term. Everything to the first power is 1. And then 1 minus, and then our r was -1 times x plus 2. So this will converge to the function 1 over 1 plus x plus 2, or 1 over x plus 3. As long as x stays within the interval of convergence from -3 to -1. So let's just label everything. Here's my interval, and here is my convergence function. So if possible, find the interval of convergence, the radius of convergence, and the function. Again, so the thing, if it's possible, okay, that is assuming it's a geometric series. So it's got to be geometric before you can move on and find all of these things. So if we plug in 0, we're going to get 1 over 1. If we plug in 1, we'll get 3x minus 2 over 5. And then 3x minus 2 squared over 25, etc. So my r is 3x minus 2 over 5. So this appears to be geometric, and so assuming that 3x minus 2 over 5 stays less than 1 in its absolute value, then we can solve. So we multiply everything by 5, which is already positive. I divide everything by 3, again, which is positive. And now I can tell the center and the radius. It's got to be in that form. So this would be centered at 2/3. And the radius of convergence is 5/3. Okay, how about the interval? So -5/3 less than x minus 2/3. And so then my interval, if I add 2/3, I'll get -1, and I'll get 7/3. And so the interval of convergence is between 1 and -7/3. As long as x holds within that interval, then we should be able to find the function. So my convergence function will be the first term, which is 1, over 1 minus 3x minus 2 over 5. So let's multiply everything by 5 to clean that up. So that would be 5 over 5 minus the quantity 3x minus 2. So then my function would be 5 over 5 minus 3x plus 2, or 7 minus 3x. So as long as x stays within that interval, So suppose x was 0, which is in the interval of convergence. Then this series would converge to, and I'd plug 0 into the convergence function, and that would converge to 5/7. Or if x was 1, which is in the convergence interval, then the series will converge to 5/7 minus 3, or 5/4. Now, can you do it backwards? If the series converges to the following function, can you figure out what the series is and what the interval and the radians of convergence are? Okay, so that's the next step. Can you do that? Well, this has to be, assuming that this is geometric, so this would be a1 over 1 minus r. Well, the a1 is pretty clear, but this function is not in the form of 1 minus r, so we need to rewrite this so that we can figure out what the radius is. So if x plus 1 is supposed to be equal to 1 minus r, then we can subtract 1 from both sides, and so r is negative x. In other words, I could rewrite this as negative 2 over 1 minus negative x. So now I know what my a1 is, and I know what my r is. So the series that this is representing is the series that starts with negative 2, and then I multiply that by negative x, so that would be 2x, and I multiply that by negative x, so negative 2x squared, and I multiply that by negative 2x, excuse me, by negative x. Okay, and so I'm getting this series, negative 2 plus 2x minus 2x squared plus 2x cubed minus 2x to the 4th. Okay, what would the interval and the radius of convergence be? Well, the interval has to be the r value between negative 1 and 1. So let's take our r value here. We're going to put it between negative 1 and 1. So multiply everything by negative 1 to solve that, which switches the signs, which is still that x is less than 1. So it's centered at 0. The interval of convergence is negative 1 to 1, and the radius of convergence is 1. All right, last one. What series is represented by this following function? Again, a1, 1 over r. So if x minus 3 is equal to the denominator 1 minus r, x minus 4 equals negative r, so r is equal to 4 minus x. So the series is the series a1 times r to the n. It's a geometric series. So a1 is 1, r to the n is 4 minus x to the n, where n starts at 0 and goes to infinity. I didn't write that very well. Let's see. One times 4 minus x to the n. Okay, so the interval and the radius, my interval is that 4 minus x has to be between negative 1 and 1. So I'm going to subtract 4. And then I'm going to multiply everything by -1. Switch my signs. So my interval is between 3 and 5. Maybe we'll write it the other way so it looks a little better. Okay, that is my interval of convergence. What would the radius be then? Well, the center of that is 4. And so another way to write that is x minus 4, absolute value, less than 1. That's the same interval as 3 to 5. And so the interval is 3 to 5. The radius, capital R, is equal to 1, and the center is at 4. All right, so work on these geometric power series using the theorem of the assumption that convergence only happens if your ratio is bounded by absolute value being less than 1. All right, I'll see you guys on Thursday. Have a good afternoon and evening.